Welcome to this video on rational equation word problems, part 2 of 3, two types of transportation. Remember some general strategies that you can use anytime you have a word problem. Circle or underline important numbers, words, or phrases. Label important information. This includes assigning variables to unknown quantities. Organize information using a table or picture, and predict what a reasonable answer would be. Let's begin. These problems involve the equation distance equals rate times time. Please note that this equation is only valid for anything or anyone that is traveling at a constant rate of speed. For example, if a car accelerates from 20 to 30 miles an hour, you can't use this equation anymore. You can only use it if you assume a constant rate of speed. So D stands for distance, R stands for the rate of travel, and T stands for time. And the equation is equal to D equals RT. You will need to memorize this equation. Let's start with our first example. It says example 5 because this is part 2 in a 3-part video series. A plane can fly 240 miles. Let's highlight 240 miles because it seems important. In the same time, it takes a car to go 80 miles. If the car travels 180 miles slower, 80 miles an hour slower than the plane, find the speed of the plane. So that is our first strategy, is to highlight, circle, or underline the parts of the problem that seem important. Remember, our second strategy is to find the unknown quantity. So we want to know the speed of the plane. So let's call the speed of the plane R. R stands for rate. Okay. Notice we have already started the organization part of our strategy. So we have our distance, we have our rate, and we have our time. And then we have the two modes of transportation, which are the airplane and the car. So we already have some of this information given to us. So let's go ahead and fill in this table. So it says that the plane can travel 240 miles. And then notice this, it says in the same time. The same time. So I'm going to call this amount of time T. We don't know what it is, but the reason it's important is because it takes the same amount of time for the car to travel 80 miles. Okay? So notice I've already filled out 2 whole columns of my table. Then it says if the car travels 80 miles an hour slower than the plane, find the speed of the plane. Okay? So we don't know how fast the plane is going, but we did assign it a variable R, right? And we know that however fast the plane is going, the car travels 80 miles an hour less than that. So a common mistake is to write it as 80 minus R. Okay, make sure you don't do that, right? It's the plane speed minus 80, R minus 80, not 80 minus R. Okay, so we have our table completely filled out. So now what do? Well, now we need to use that equation, D equals R times T. And we're going to have 2 equations, one for our plane and one for our car. So the plane goes 240 miles, right? So we have 240 equals R times T. So this is one equation. Okay, then we have a second equation. Our second equation is 80 is equal to R minus 80 times T. Okay, so let's think about what we can do with these 2 equations. What we really want to find is we want to find R. In other words, we don't really care what T is. T is just a variable that's helping to connect these 2 equations, right? So what we're going to do is we're going to try to eliminate T. So how can we do that? Well, we can eliminate T by solving one equation for T, okay, and then substituting that expression into the other equation. So take a minute, stare at these 2 equations, and figure out which one do you think would be slightly easier to solve for T. I think the first equation might be a little bit simpler. So we have 240 is equal to R times T. So let's ask ourselves, how is the R attached to the T? Well, they're attached by multiplication. How can I isolate my T? How can I solve for T? Well, what I need to do is I need to divide both sides by R. So I have the expression t is equal to 240 divided by r. So now what we're going to do is we're going to take this new expression and we're going to substitute it for t in our second equation. So our second equation becomes 80 is equal to r minus 80 times, not t anymore, but instead of t, what are we going to write? We're going to write 240 divided by r. Okay, so let's take a minute and look at that, think about it. Does this look like anything? Does it remind you of anything? Well, let's rewrite it a little bit. What if we write it as 80 is equal to 240r minus 80 over r? Does it look like anything now? What if we write it like that? Does this look like a proportion to you? Because it is. We have a over b is equal to c over d. Now the expression c, this thing is kind of a little bit messy, but it's still valid. So do you remember how we solve proportions? So what we need to do is we need to cross multiply and solve. So we're going to do 1 times 240 times the quantity r minus 80. So 1 times 240 times r minus 80 is equal to 80 times r, or 80r. Okay, look at that. We now have a linear equation that we can really pretty easily solve, right? So let's just do that. So we can distribute this 240. Okay, so we have 240 times r, so that's 240r, minus 240 times 80, that is 19,200. Okay, and that's going to be equal to 80r. Kind of running out of room here. Uh-oh. So what can we do? Well, I'm going to subtract 240r from both sides of my equation. Okay, so I now have negative 19,200 is equal to negative 160r. Right, and then last but not least, I'm going to divide both sides by negative 160. Okay, so when I do that, when I type that into a calculator, I get positive 120 miles an hour. Okay, so let's just take a minute and think about if that makes sense for a speed of a plane. It's definitely too fast for the speed of a car, but you can imagine that a plane could go that fast. I would have thought that a plane needed to go a little bit faster in order to stay in the air, but you know what? I'm not a pilot, so we'll go with it. If I had gotten something like 20 miles an hour, or if I had gotten a negative rate, then I definitely would have been known that I made a mistake and would have had to go fix it. All right, let's do another one. So this is almost identical. You can see that we've just sort of changed the numbers here, right? So a plane can fly 850 miles. So that's my distance. In the same time, t, it takes the car to travel 300 miles. Okay, so if the car travels 110 miles slower than the plane, so the plane will say that it goes r miles an hour, so the car is then r minus 110 miles an hour, then we need to find the speed of the plane. So in order to continue, what we really need to do is we need to pull out that equation, which is d is equal to rt. Distance is equal to rate times time. So for our plane, we have 850 miles is equal to the rate times the time. For the car, we have 300 miles is equal to rate minus 110 times the quantity t. All right, so just like last time, what we're going to do is we are going to solve one equation for t, okay, and then we're going to substitute whatever expression we get in place of t in the other equation, okay, because again, we don't really care about the time, right? I don't care how long it took. I could find that answer, but that's not what they're asking me. What are they asking me for? They're asking me for the speed of the plane, and remember, the speed of the plane is the variable r that we've defined. All right, so let's get started. So just like last time, I'm going to pick the simpler of the two equations. I'm going to isolate t by dividing both sides by r. So we have 850 over r is equal to t. Okay, so what are we going to do with this information? Well, instead of t, in this equation, I'm going to substitute the expression 850 over r. So this becomes 300 is equal to r minus 110 times 850 over r. Okay, so again, remember last time we rewrote it so that it became visually apparent that we're really looking at a proportion. Okay, so you can write it like that. So remember, we can cross multiply like this, and then we can solve very easily. So we're going to have 300 times r is equal to 1 times 850 times r minus 110. I'm going to use the distributive property, so we have 300r is equal to 850r minus 93,500. So now what should we do? Well, we're going to get all of our variables on one side. I'm going to do that by subtracting both sides, subtracting 850r from both sides. Okay, so this gives me negative 550r equals negative 93,500. So make sure you keep track of those negative signs. Both sides are negative. So a negative, remember, divided by a negative is a positive number. So when I divide, then I get r is equal to 170 miles an hour. Okay, and again, we use that last step of prediction and try to make sure that that makes sense in the context of the problem. So plane flying 170 miles an hour seems reasonable. Okay, we have one more example here. It says a woman can bicycle 75 miles. So let's fill that in, 75 miles in the same time, so we'll call that t, as it takes her to walk 15 miles. And that makes sense, right? Because bikes are much faster than walking, so you can traverse a lot more distance on a bike than you can on foot. Okay, so again, the time is the same. All right, then it says that she can ride 10 miles an hour faster than she can walk. How fast can she walk? Okay, so we're going to call her walking rate, we're going to call that r. I'm going to put an r here. Okay, and we know that whatever her walking rate is, we know that her biking rate is 10 miles an hour faster than that, or r plus 10. Okay, so once again, we're going to use that equation, d is equal to rt. Okay, so we'll have 75 equals r plus 10 times t, and then we have 15 is equal to r times t. Okay, so we're going to do the exact same procedure as the last few problems. We're going to solve this equation for t. We're going to solve it for t by dividing both sides by r. So we have 15 over r is equal to t. Then what we're going to do is wherever we see t in this other equation, we're going to replace it with 15 over r. So this becomes 75 is equal to r plus 10 times, not t anymore, but 15 over r. I'm going to write it like this. Okay, and write it like this so that it's clear that I now have a proportion, which I can then just cross multiply and solve. So we get 75 r equals r plus 10 times 15. We can then use the distributive property over here. We get 15r plus 150. Okay, then once again we're going to solve for r. Oops, sorry about that. 15r. So this becomes 60r is equal to 150. So we're going to divide both sides by 60. And we find that her walking speed is 2.5 miles an hour. Okay, so as always, we want to ask ourselves, is this a reasonable walking speed? Is it reasonable to think that you could walk at 2.5 miles an hour? This would mean that she's biking at 2.5 plus 10, or 12.5 miles an hour. To me, that sounds very reasonable. I think that I could probably walk 2.5 miles in a single hour. I could probably do that. I could probably even walk faster than that. So this, again, sounds right to me. It makes sense in the context of the problem.